Hey everybody, in this video we're looking at example 2 in section 4 of rational inequalities. For more in-depth analysis and explanation, please check out example 1 in this series, example 1 for section 4, and even more detail, check out example 1 in the polynomial inequalities. So that'll be section 3, example 1, to get a full breakdown on the technique, strategy, hows, who's, what's, and whys. All right. But for this example, let's get started. It's already got 0 on one side. I'm going to find the key components of the graph, figure out when this graph is on or below the x-axis. So what do I have going on? Well, my x-intercept, in this case I have only one x-intercept, will be at 5, 0. I got that by setting the numerator equal to 0. The local behavior of my x-intercept is going to be quadratic because of that multiplicity of 2 on the factor. So my graph will touch at 5 and bounce off either looking like that or like this, depending on other information. Next, I'm going to write down my vertical asymptote. I get that by setting my denominator equal to 0, and that will be the line x equals -1. That is also going to have an even multiplicity, so that means my branches will be both pointing in the same direction, either both up or both down. After that, my y-intercept, we get that by filling in 0 for x. -5 in parentheses squared is 25 over +1 squared. Again, I'm filling in 0 for x for that expression. And my y-intercept is 25. I'm mostly concerned with the fact that I have a positive y-intercept. And then last, my end behavior. Leading term over leading term. When fully expanded, this will be x squared over x squared, which reduces down to 1. So my end behavior is along the line y equals 1. So if I just quickly do a little sketch of this information, it will give me 25 as my y-intercept, +1 as my end behavior, -1 as my, let's just go right there, as my vertical asymptote, and 5 as my x-intercept. Now I know I definitely have to cross through the 25, and I know I also have to get to that x-intercept. For the millionth time, you can cross what we call our horizontal asymptotes. Again, I call it end behavior for this very reason. You can cross it. It's more about the end than it is about the middle. I have quadratic behavior here, but my ends, as I go out further toward infinity in the x direction, I am approaching the value of 1. I'm going to get closer to 1, yada yada. And now, because of the fact that my asymptote has even behavior, my branches on either side of my vertical asymptote will both point up. And there I go. That's going to be my graph right there. Now the question's asking me, when is this less than or equal to 0? Well, it equals 0 there. It is never less than 0. So this is almost a no solution problem. However, we have one itty bitty baby solution. The answer is only at the value of 5. Since it's not an interval from here to here, I'm not going to use interval notation. I'm just going to use the set of the only including the value of 5, because that is the only time, and we are equal to 0 there, but we are not less than 0 anywhere. And that's the end of this example. If you can appreciate, go ahead and give a thumbs up. If you just hate everything, go ahead and give a thumbs down. Oh wait, where's my thumbs up guy? Thumbs up. Questions, comments, concerns, feedback, requests, put it in the comment section. Check the description box or the playlist on your screen for more videos on this topic, or find a different playlist for a topic that is going to be useful to you. All right, that's it for now. Adios.